What if I told you that one of the first meals humans ever shared wasn't meat, fruit, or fire-roasted anything, but bone marrow sucked straight from a shattered femur, or that your ancestors might have survived droughts by feasting on beetle larvae and roasted grasshoppers? Forget what you think you know about cavemen diets, because what they actually ate might turn your stomach and blow your mind. How did early humans survive in a world where food wasn't guaranteed? What strange, ingenious, or revolting things did they consume to keep the species alive? Let's dig into the real prehistoric menu. Chapter 1. The bone crack that changed everything, set in a time long before supermarkets, fire-lit kitchens, or even spoken language. A time when the difference between life and death often came down to what you could crack open, suck out, or scavenge. The African savanna at dusk was no place for the weak. Early humans, lean and hungry, gathered around a freshly killed antelope, but they weren't interested in steaks or tenderloins. One of them picked up a heavy rock, smashed open the animal's femur, and began slurping out the soft, rich marrow inside. A move that seems grotesque today, but was, in that moment, a life-saving innovation. Another member of the group took a sharp stone, cracked open the skull, and gently extracted the brain matter, careful not to waste a drop. These weren't desperate acts of starvation, they were calculated, strategic behaviors repeated generation after generation. This was survival science in action, and it changed everything. Long before humans mastered agriculture or fire, they were mastering fat, marrow, and brains, specifically because these parts of the animal were loaded with calories and nutrients, especially fats critical for brain development. Our ancestors didn't just stumble on this by accident. In places like Cavemen Cave near modern-day Tel Aviv, researchers have found evidence that early humans stored bones for weeks, sometimes longer. These weren't leftovers. They were prehistoric food cans designed to preserve precious marrow during lean times. Bones with dried skin and sinew were set aside and then cracked open when meat was scarce, revealing still edible high-energy marrow. This behavior paints a very different picture of prehistoric life, not as chaotic and desperate, but as inventive, strategic, and shockingly efficient. A single long bone from a large animal could contain over 1,500 calories. And in a world where hunting was risky and unpredictable, every calorie mattered. Marrow wasn't just food, it was insurance. And the same applies to brains. Across countless archaeological sites, from Ethiopia to Spain, skulls with deliberate impact fractures tell a clear story. The brain was too valuable to leave behind, rich in omega-3 fatty acids and micronutrients essential for neurological function. Animal brains offered what plant foods could not. These fatty acids are particularly important for fetal development and early childhood growth, which means they were critical to the survival of not just individuals, but entire communities. Evolution doesn't reward the squeamish, it rewards the adaptable. And early humans were nothing if not adaptable. They didn't simply eat what was available, they figured out how to extract the maximum nutritional value from every part of an animal, including the parts most predators ignored. In fact, scavenging bones after other predators had eaten the meat may have been one of the first ways humans got consistent access to animal nutrients without taking on the risk of hunting. But eventually, they became hunters themselves, tracking and killing animals with increasing skill. And when they brought the kill back, it wasn't the muscle meat that was prioritized, but the nutrient-rich organs and bones. There's even evidence that our ancestors developed tools specifically for cracking skulls and bones, shaping the evolution of our hands and grip strength in the process. University of Kent researchers have proposed that the act of smashing bones influenced the physical evolution of the human hand, giving us the power and precision grip we use even today. This is how intertwined diet and evolution truly are. What we ate changed how we lived, how we thought, and even how we were built. And it didn't stop there. The consumption of marrow and brains was part of a larger pattern of resource maximization, where nothing went to waste and every part of a kill was put to use. Fat was rare and highly prized, far more important than the lean meat we favor today. In a calorie-scarce world, our ancestors weren't seeking flavor or presentation, they were chasing survival, and bone marrow offered a direct, energy-dense pathway to that goal. What's remarkable is how this ancient practice still echoes in our biology. The human brain consumes about 20% of our body's energy, far more than any other primate. That high metabolic cost had to be supported somehow, and researchers now believe that fat-rich foods like marrow and brains were critical in making that possible. Without them, our big brains might never have evolved at all. So the next time you think of cavemen as brutish, primitive, or simple, remember that it was a cracked bone and a mouthful of marrow that helped kickstart the very intelligence we now use to look back on them. Chapter 2. Bugs, Beetles, and Breakfast. The insect diet of prehistoric humans. Long before protein bars and multivitamin gummies, our ancestors had their own superfoods, and they came crawling, squirming, and flying through the forest, savannas, and grasslands of prehistoric Earth. To modern palates, the idea of popping a handful of termites or crunching down on a beetle larva might seem revolting, but for millions of years, insects weren't a weird exception. They were a normal, essential part of the human diet. And the evidence isn't just in ancient tools or cave paintings. It's written directly into our DNA. Our closest primate relatives, including chimpanzees and bonobos, still actively seek out termites, using twigs as tools to fish them from their mounds. This behavior is so widespread and consistent that scientists believe it stretches all the way back to our last common ancestor around 6 million years ago. That means humans didn't start eating bugs. They never stopped. In fact, fossilized human feces from ancient sites around the world have repeatedly turned up insect remains, crushed exoskeletons, wing fragments, and the unmistakable residue of tiny legs. These weren't one-time meals of desperation, they were everyday sustenance. Insects were plentiful, easy to gather, and packed with protein. Some species offer more protein per gram than beef, along with healthy fats, fiber, and important micronutrients like iron, zinc, and B12. Even better, they were predictable. While hunting a large animal might take days and could end in failure, bugs were always around. During droughts, harsh winters, or failed hunts, insects became a vital fallback food, reliable, nutritious, and often abundant year-round. Prehistoric humans understood this balance intimately. Archaeological evidence from caves in Spain, dating as far back as 30,000 BCE, shows detailed depictions of people harvesting wild bee nests and gathering edible insects, suggesting that these tiny creatures were considered valuable enough to be recorded in early human art. This wasn't novelty eating, it was survival, recorded with pride. And even when more advanced tools allowed for better hunting of birds and mammals, insects remained on the menu. Grasshoppers, crickets, beetle larvae, and ants were routinely collected and eaten raw, roasted, or even ground into paste. These practices still survive today in many parts of the world, not as ancient holdovers, but as respected food traditions. In Thailand, fried locusts are sold by street vendors. In Mexico, chapulines, roasted grasshoppers seasoned with lime and chili, are a popular bar snack. And in parts of Africa and Southeast Asia, termites are a seasonal delicacy eaten by the millions. These aren't cultural oddities. They are living connections to a prehistoric strategy that fed billions over millennia. Beyond their nutritional value, insects were an efficient resource. Unlike cattle or pigs, which require enormous amounts of food, water, and space, insects can thrive on very little and reproduce rapidly. In evolutionary terms, this made them a nearly perfect food source. They didn't just feed individuals, they supported entire populations through lean times and changing climates. Our ancestors figured this out instinctively, adjusting their diets based on local availability. For coastal tribes, it might have been shellfish. For forest dwellers, it was beetles and caterpillars. In the savanna, it was grasshoppers and termites. No matter the environment, humans learned to exploit the resources that were most consistent and energy-dense. And in most cases, that meant bugs. The impact of this dietary choice is still felt in our biology. Some scientists believe that the enzymes in our digestive systems, which help us break down tough proteins and chitin, the material in insect exoskeletons, are a legacy of our bug-eating past. Even our immune systems and microbiomes may have been shaped by regular exposure to the microbial ecosystems living on and in insects. In other words, we didn't just eat bugs, we evolved with them. But perhaps most surprising of all is how modern attitudes have drifted so far from this ancient reality. Today, eating insects is often seen as a dare, a punishment on a game show, or a cultural curiosity. Yet for the vast majority of human history, it was simply dinner. It was practical, sustainable, and vital. The prehistoric diet wasn't about prestige or preference. It was about what worked, and insects worked incredibly well. So while you may never crave a roasted beetle skewer or a crunchy handful of termites, just remember, your ancestors probably did. And without them, you wouldn't be here. Chapter 3. Roots of Survival, Tubers, Fire, and the Forgotten Power of Plants. When we picture prehistoric humans, we tend to imagine rugged hunters chasing mammoths across frozen tundras, spears in hand, triumph written in the blood of freshly slain beasts. But that picture is only half the truth, if that. The quieter, often overlooked reality is that plants, not animals, may have been the true backbone of early human survival. And among these plants, none were more critical than tubers. Those humble, starchy, underground powerhouses that fueled our ancestors for hundreds of thousands of years. Wild yams, cattail roots, water lily tubers, these weren't just side dishes, they were staples. In fact, recent discoveries suggest that for many prehistoric communities, especially in Africa and the Middle East, tubers were a more consistent and primary source of calories than meat. In the modern Tanzanian savanna, for example, researchers have documented around 40,000 kilograms of edible tubers per square kilometer, an overwhelming abundance that ancient foragers would have known well. The raw versions were tough, fibrous, and bitter, but edible nonetheless. And then came the game changer, fire. When humans began to control and use fire, not just for warmth and protection, but for cooking, it transformed the human diet permanently. Fire made these tough roots soft, unlocked the starch inside, and made them far more digestible and energy-rich. Before cooking, much of the starch in tubers would pass through the digestive system untouched. After cooking, the calories became accessible, efficient fuel for our metabolically demanding bodies and brains. The connection between cooked plant food and human evolution is now widely accepted among anthropologists. Some even argue that the shift to cooking food, particularly carbohydrate-rich roots and tubers, is what enabled the dramatic increase in brain size around 800,000 years ago. It wasn't just about eating more, it was about digesting more, faster, and with less energy spent chewing and processing. Cooking, quite literally, gave us more usable fuel, and our ancestors didn't stop at throwing tubers in the fire. Evidence from Shanidar Cave in Iraqi Kurdistan shows Neanderthals were adding herbs like wild mustard to their cooked plant meals as far back as 70,000 years ago. These weren't just survival foods, they were evolving into something more complex: early cuisine. People weren't simply surviving on plants, they were experimenting, combining flavors, and passing knowledge from generation to generation. This plant-based innovation also had a major advantage over meat: reliability. Hunting was risky, weather-dependent, and often unsuccessful, but tubers were stationary. They didn't run, they didn't hide, and they grew in the same places year after year. Foraging groups could rely on these plants even in the harshest conditions. When game was scarce or hunting failed, it was the ground beneath their feet that saved them. Toothwear patterns from ancient skulls also support the story. Microscopic scratches on fossilized teeth show the heavy presence of grit and fibers, consistent with diets full of tough, fibrous plant material. Even dental calculus fossilized plaque has revealed trapped plant particles, starch granules, and phytoliths, tiny mineral structures found in plants, proving that early humans consumed a wide variety of edible flora, from seeds and nuts to tubers and greens. And the benefits went beyond just calories. Many wild tubers are rich in antioxidants, minerals, and slow-digesting carbs, ideal for providing sustained energy and supporting physical endurance. For mobile hunter-gatherer groups, these properties were crucial. A belly full of roasted roots meant not just survival, but stamina, focus, and the ability to keep moving. The evolutionary fingerprints of this ancient plant diet remain etched into us today. Our saliva contains enzymes like amylase, designed specifically to break down starch. The number of amylase gene copies varies by population, often correlating with how heavily their ancestors relied on starchy plants. This genetic variation is yet another reminder that food didn't just nourish us, it shaped us. So, while fire-roasted meat may be the symbol of prehistoric success, it was the quiet, reliable tuber that carried early humans through famine, migration, and millennia of survival. They were the original survival ration hidden beneath the soil, waiting to be dug up, softened by fire, and transformed into the energy that fueled our ancestors' next steps. In the end, the roots of our species weren't just metaphorical, they were literal. Dug up, roasted, and eaten by firelight, they helped build the brains that built the world. Chapter 4. Fermented, foraged, forgotten. The hidden science of early human gut health, long before kombucha lined grocery shelves and gut microbiome became a wellness buzzword, early humans were already mastering the microscopic world without even knowing it. As they scavenged meat, gathered roots, and feasted on insects, they also began to stumble into a biological relationship more intimate and powerful than any tool or fire: their internal ecosystem. Every bite of raw plant, spoiled fruit, or aged marrow teemed with bacteria, not all harmful, but many essential. And over generations, these invisible companions didn't just live inside us, they evolved with us, shaping everything from digestion to mood, immunity to metabolism. In the wild, fermentation happened naturally. A pile of overripe fruit left in the sun turned fizzy and alcoholic. A forgotten animal hide filled with milk began to curdle into cheese. A broken tuber buried in damp soil started to sour. These weren't accidents to avoid. They were often the tastiest, most digestible versions of difficult foods. Fermentation, though likely discovered by chance, became an ancient ally, a method of predigestion that reduced toxins, enhanced nutrients, preserved perishables, and introduced vital probiotic bacteria into the gut. This silent partnership between humans and microbes may have been crucial in expanding our dietary range. Tubers that were too tough to chew raw, or seeds filled with natural defenses like phytic acid, could be fermented into something gentler. Early human groups likely learned by observation, eating what didn't kill them, remembering what eased the stomach or improved endurance. In tropical regions, cassava, toxic when raw, was soaked, sun-dried, or fermented into a safe, starchy staple. In colder climates, meat was buried in snow or moss to sour and age, gaining complexity and bacteria that helped preserve it and enhance its nutritional punch. But the relationship went deeper than digestion. Scientists now know that the human gut microbiome, the trillions of bacteria, viruses, and fungi that live in our intestines, isn't just a passive stowaway. It affects nearly every system in the body. It trains our immune cells, regulates inflammation, even influences neurotransmitters like serotonin and dopamine. Our microbial diversity is linked to everything from mental health to autoimmune resilience. And the origins of that diversity, they lie deep in our evolutionary past, when we lived close to the soil, ate food with our hands, and shared meals that were never sterile. For early humans, nothing was pasteurized or vacuum sealed. Everything was touched by life, fermented in pits, dried in smoke, soaked in streams, or aged in skins and leaves. And every region developed its own microbial signatures tailored to local diets. Hunter-gatherers in Central Africa still host gut bacteria capable of digesting a wide array of complex plant fibers, bacteria now largely absent in urban populations. In traditional pastoral communities, bacteria adapted to milk consumption dominate. These microbial fingerprints show how deeply diet and environment shaped the inner workings of the human body. Unfortunately, that microbial legacy is under threat. Modern hygiene, processed food, antibiotics, and environmental changes have slashed microbial diversity in many parts of the world. Compared to our ancestors, modern guts, especially in industrialized nations, harbor fewer species, less resilience, and more imbalance. And with that loss comes a spike in digestive disorders, allergies, chronic inflammation, and even mood disorders. In trying to eliminate germs, we may have also eliminated allies. But the story isn't just about loss, it's about rediscovery. As researchers uncover the intricate connections between food, microbes, and health, they're finding that ancient eating patterns may hold the key to modern well-being. Fiber-rich diets, fermented foods, and seasonal variety, all hallmarks of prehistoric nutrition, nourish the microbiome in ways fast food never could. Whether it's raw honey full of natural enzymes, sun-dried fruits covered in wild yeast, or tubers eaten with the soil still clinging to their skins, our ancestors were constantly feeding not just themselves, but the life inside them. And perhaps most fascinating of all, the microbiome may have shaped our evolution just as we shaped it. Emerging theories suggest that gut bacteria can influence appetite, cravings, and even mate selection. It's possible that certain traits we now associate with human success, social bonding, language fluency, emotional regulation, were subtly guided by the microscopic citizens within us. Evolution wasn't a solo project, it was a collaboration. So while we often credit our survival to fire, meat, and ingenuity, there's another quiet hero in the human story: the trillions of microbes that have shared our journey from forest to farm, cave to city. They digested what we couldn't, protected us from within, and evolved alongside us. One fermented root, one rotting fruit, one mouthful of marrow at a time. In the end, what makes us human may not just be what we eat, but what eats with us.